Let's look at velocity time graphs for accelerated motion. Velocity is the rate of change of position. It's a vector, so it has magnitude and direction. The magnitude tells us how far it goes in how much time, how much the position changes per time, the displacement per time. That's the magnitude. For linear motion, the direction tells us which way it's heading, whether it's heading to the right or to the left if it's horizontal. In these examples, we're going to take a heading to the right to be positive and to the left negative. So let's look at some velocity time graphs, some VT graphs for accelerated motion. Notice that the first two examples have positive velocity all the time. The next two examples have negative velocities all the time. That means that in the first two cases, the object is heading or moving in the positive direction. In our case, it means it is heading to the right. It doesn't matter where it is, whether it is on the right or on the left. We could say to the right or to the left of the reference point. That is not relevant to velocity. That is only relevant to the sign, positive or negative, of position. But for velocity, a positive velocity just means it's moving towards the right, heading towards the right. So in both of these cases, the object is going to move towards the right. And in both of these cases, the object is going to move towards the left. Its position is going to become more and more negative, more and more left, further and further to the left. So for both of these two, the velocity is positive. It's heading to the right. But what's different between them? In the first case, the object starts at rest, standing still, velocity 0, and then it gets faster and faster. It's speeding up. In the second case, the velocity starts at a high positive level. In other words, when we start watching it, it's already quite fast, and then it gets slower and slower until it stops. It's slowing down. So here we have the man. The whole time he's going to move to the right. His velocity will be positive. But in the beginning, he's going to be standing still. Let's watch him. And now he gets faster and faster. He accelerates. Now let's observe this man slowing down, moving in the positive direction. So all the time he's going to be heading to the right. Doesn't matter where he is though, but he's heading to the right. But when we start observing him, notice he's going to already be moving, and he gets slower and slower until eventually he stops. So in this case, he is decelerating, which is a type of acceleration. He is slowing down, decelerating. In both of these cases, the man is going to head to the left. He's going to move towards the negative direction, the left. What's different between the two is that in the first case, he starts at 0 velocity, standing still, and he gets faster and faster. And in the second case, when we start observing him, he's already moving, and then he gets slower and slower. So he's going to be standing still in the beginning, and now let's watch him. He gets faster and faster all the time, heading to the left, moving in the negative direction. In comparison, let's watch him when he slows down while moving in the negative direction. Notice when we start to observe him, he's already going to be moving quickly. And now he slows down all the time, moving in the negative direction, moving towards the left. His velocity is negative, but changing from quick to slow, actually from maximum to standing still, regularly changing. In other words, accelerating. So he is also decelerating because he starts quick and he goes slower and slower. So he decelerated.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!